Hello everyone. In this video, we'll understand how do you solve a game problem if it has got two rows and any number of columns. So you say 2 by n type of game. How do we solve it using graphical method? So here the problem is consider the payoff matrix of player A as shown below. Solve it optimally. Right. So the very first step is to find out the row minima and column maxima, whether it has got any saddle point or not. That is the first thing we are supposed to check. So here the minimum is -6. Here the minimum is -9. Here maximum is 7, 2, 7, 4, and 8. So max-min value is max of -6 -9, which is -6, and then minimax value is minimum of all the column max values 7, 2, 7, 4, 8. So the minimum is 2. So of course here max-min value is not equal to minimax value. So this game do not have a saddle point. Hence, this game do not have a saddle point. Then once you conclude this, that means that the players are adopting mixed strategies. The next step is to find out whether there is any dominance between each column, because rows already we have got 2 rows, so we'll check for dominance. Only for columns we'll check. Right. So now first column versus second column. We may note 4 is larger than 2 and 7 is larger than -9. So I can say from this, this implies that C1 is greater than C2. That means which is dominating? C1 is dominating column. And can be deleted or eliminated. So now we will proceed comparing C2 with other columns. C2 versus C3. 2 is lesser than 5, -9 is lesser than 7. 2 is lesser than 5 and -9 is lesser than 7. So I can say C2 is in general lesser than C3. That means here C3 is dominating column and can be deleted. Now we'll compare C2 versus C4. Okay. 2 is greater than -6, whereas -9 is lesser than 4. So no dominance, I can straight away write. Though no dominance found. Then C2 versus C5. Let us check that. 2 is lesser than 6, -9 is lesser than 8. So 2 is lesser than 6 and that 2 is lesser than 6, -9 is lesser than 8. So this I can say C2 is lesser than C5, which means C5 is dominating. straight away 3 columns are getting eliminated. So it becomes a 2 by 2. You need not solve it graphically in this case, even though the question talks about, the title talks about graphical method. Actually, we need not do graphical. So the revised payoff matrix will be what? Will have all these 3 columns will be eliminated. C5 can be, C5 is dominating, means C5 can be deleted. So C1, C3, C5, 3 columns are getting deleted then. So now it will become simply a 2 by 2 matrix. So what are getting deleted? C1, C3 and C5. So we will have only second strategy and fourth strategy for player B. Here we have 1 and 2 for player A. So 1, 2, that is 2 minus 9. And then for fourth, minus 6, 4. Now we can say let P1, P2 be the probabilities of player A adopting his strategies 1 and 2 respectively. Similarly, let Q1, Q2, Q3, Q4 and Q5 be the probabilities of player B adopting his strategies 1, 2, 3, 4 and 5 respectively. Already we noticed that strategies 1, 3 and 5 are deleted for B, player B. I'll say since strategies 1, 3, 5 are deleted for player B, we have Q1 is same as Q3 is same as Q5 and all that will be 0. And we also know P1 plus P2 equal to 1, which means P2 will be 1 minus of P1. Then Q1 plus Q2 plus Q3 plus Q4 plus Q5 will be 1, which is the same as Q1 is 0, Q2, Q3 is 0, Q4, Q5 is 0, which means I can say Q4 is the same as 1 minus of. So with this, we'll go back and write the probabilities in red color just to have a better understanding. Here it will be Q2, here it will be Q4. Now let us calculate the oddments for each row. Here it will be -9 minus 4, so it becomes 13. Here it will be 2 minus of -6, so it will be 8. Here it will be -6 minus 4, column oddment. Here it will be 2 minus of -9. So this is 10 and this is 11. Now let us calculate the probabilities. We have P1 equal to, the corresponding oddment is 13 divided by sum of that oddments in the rows So it becomes 13 by 21, which means our P2, which is 1 minus of P1, will be 1 minus of 13 by 21. And that will be 8 by 21. Then let's calculate Q2. What is the corresponding argument? 10. 10 divided by 10 plus 11, which is 10 by 21. That means our Q4, which is 1 minus of Q2, will be 1 minus of 10 by 21. That will be 11 by 21. So we got the strategies now, optimal strategies. For A, it will be P1 is 13 by 21. The probability of player A adopting his first strategy is 13 out of 21. And P2 will be 8 out of 21. For B, the probabilities will be Q1 is 0, then Q2 is 10 by 21, Q3 is 0, Q4 is 11 by 21, and then Q5 is 0. That will be the optimal strategies for player B. Now we can find out the value of the game. We can write down the expected value function like this: 2P1, 2 times P1 minus 9 times P2. 2P1 minus 9P2. 2P1 minus 9P2. So it is 2 times, what is P1? 13 by 21 minus 9 times 8 by. So this is 26 minus 9 8s are, I'm sorry, 9 8s are 72 by 21. So we may know that the value is 646 minus 46 by 21. Means this is actually, in negative means it is actually favoring the player B instead of favoring player A. Right. So in case if you find the contents of this, see here actually we thought that we will be landing up with graphical method for solving this problem, but we need not use graphical method because we could able to delete or eliminate 3 columns. So what happened is that instead of becoming 2 rows and 3 columns, or 2 rows and 4 columns, or 2 rows and 5 columns, it has become already 2 by 2. 2 by 2, once it has become, means you need not use graphical method. Straight away we can use the ornament algorithm. So we'll see some other problem where we can apply graphical method where it is really required. Right? In case if you find the contents of this video to be useful to you, I request you to please like, share it with your friends, and also subscribe to my channel. Thank you. There is a small error in the optimal strategies what I wrote for player B. Here it should be 21 instead of 12 what I wrote. Let me correct it. It should be 11 by 21. I think otherwise it is okay.